If we're in amplitude and period of the sine and cosine functions, today is where you kind of get the idea of how to graph these by hand. We have a little formula to calculate period. It's not that number, okay, but that's what affects the period of the graph. So we stretch it or shrink it sideways. Okay, so we're stretching vertically, stretching horizontally. Okay. So I'll show you an amplitude change, right? The amplitude is 2. Whoop, that's not what I want. What was the standard amplitude for sine and cosine? Yeah, 1, right? So we would go from 1 to -1, but now it's 2. So all we're going to do is stretch it up to 2 and down to -2. Okay. Still the same period. Okay. It repeats at 2 pi, but we're going to stretch it up here and down to here now. Okay, so we've just stretched it vertically. Okay. And again, scientifically, in the physics of it, when you turn the volume button up on your stereo, that's what's happening. Okay. The speakers thump louder. Okay. That should be easy enough for you. I have no problems knowing you can do that. What if I throw a negative in front of it? Remember parent functions, what does that do? Reflects it? Okay, upside down is probably right, but what mathematically, how would we describe it? About the x-axis, yeah. So it's going to take everything and just turn it up on end. Like that. Okay. Yeah, that's the same thing. Yep. Yep. Good observation there. Basically, or you can describe it as shifting it by pi units. Yep. Awesome. I like it. Okay. So there's amplitude. It's pretty basic. Okay. For purposes of your project, you can pick whichever amplitude you want. I would just use 1 when you graph it. It's easiest. Okay. But you will need to describe what that does in music terms. It's in the rubrics, so be aware of that. Okay, period. We rewrite the function. Okay. If I'm just putting a single number here is the intent. Okay. With the original, I have a 2 pi b. That's all the same as k. Right. So just to make it simple, we use k. The period of this function is 2 pi over k. So if I take this, just the parent function, what's the k value? Somebody said it. 1, yeah, the k value is 1, right? So the period is 2 pi over 1, which you already know, right? The period's 2 pi for the parent graph. So what does that have? What kind of effect does that have on it, the graph? Okay. See, this is not one we can do by a shift. No, because it's actually a stretch or a shrink. Okay. So like if you take a spring and stretch it or compress it, so shifting it won't figure that out. The period, this is k, right? So the period is 2 pi over 2. So it's just pi. Yeah, so it takes the whole thing and puts it in pi units, right? So let's go ahead and graph it. The amplitude is 1, correct? So I'm just going to do 1 to negative 1. I know that cosine starts at 1. Halfway, it goes to negative 1. Come on. You know you want to do it. There you go. And ends at 1. So my graph just goes from 0 to pi instead of 0 to 2 pi. Okay. So it repeats every pi units. If I wanted to, I could keep going, right? Because it's a periodic function. So basically what you're looking at, there are 2 ways to look at this. That can say, okay, it repeats twice on the original parent function. The parent function repeated at 2 pi. This is going to have 2 of them in it now. Okay, it's one way to look at it. Or you can just look at it as 2 pi over 2. It repeats every pi units. It's the same thing. Okay. You good with that? Okay, let's talk about music then. What if I gave you the C note? Here's the equation. The amplitude is 1 here, right? What's the period? This is our k value. Okay, so 2 pi over 2 pi 262.6. Yeah, this is why I recommend leaving the 2 pi there, right? So it just falls away. They cancel. So the period is 1 over 262.6. And in our case, what does the x-axis represent? What is in context of the problem? What does the x-axis represent? If the y-axis is volume, what's the x-axis? Time. In seconds. That sound wave repeats every 1 over 262.6 seconds. Okay, so if we throw that in a calculator, what decimal is that? Anybody? To be like 0.0038. So every 0.0038 second, that sound wave repeats itself. Okay. Now we can get into things like the highest frequency the human ear can hear. If I remember right, it's like 20,000 hertz. How many repetitions is that per second? What's 1 over 20,000? Anybody? What? Yeah. So you're getting 20,000, your eardrum's moving 20,000 times per second. When you think about that, it's pretty amazing, isn't it? Or, I don't know. Yeah, all right. But what about like the low range? You guys like to thump around with subwoofers, right? You know, the lowest we can hear is about 20 hertz. Okay, that's only 0.05. All right, so we have quite a range, whereas a lot of animals will actually hear from like 5 hertz all the way to 40,000, 60,000, 100,000 hertz. Okay, dogs are pretty amazing in that respect. And that's why they have those little high-pitched whistles that we can't hear, but the dogs can, because they can hear those frequencies. And of course, as you age, that number gets lower. That's why you guys with your little iPhones can ring out that 25,000 hertz symbol and we can't hear it. That was pretty popular about 5 years ago. Didn't bother me a bit. Okay, so you will have to calculate the period of your functions. So that's how you calculate that, okay? I think I think that's it. That book that I pretty much showed you, so it runs right along. Sure. On the final, it's one of the level 4 problems for the semester final is a music-based question, somewhat similar to writing the equation, finding the period, graphing it, etc. Okay, so be aware that if you want to earn that 4, this is where you need to be, because I'm not giving you a written chapter 6 test. It's just going to be the semester final. Yeah. No. The period of this function, 200, so the frequency of C is 262.6 hertz. Okay, this is cycles per second. So 1 second, 262.6 periods pass by. Do two of these every second. So the period is 1 over 262.6, so 0.0038 seconds. That's how long it takes for this to pass by your eardrum. Okay. Are there any other questions like that? Are you good? Okay. Oh, I forgot to get the cart, didn't I? Did somebody sneak over to Jansen's room and grab the Chrome cart? Very, very quiet.
I'll make noise.
I bet you would. If he asks, tell him I sent you. Okay. Here's your work, practice work. We'll score it Tuesday.